Okay, hi guys. It's day 7 and block 1. So today, or block 1 is going to be a lot of vocabulary and actually a lot of proofwriting. We're going to start to use that crazy acronym CPCTC and then incorporate a couple other vocabulary terms with triangles into some proofs. So let's get started with this corresponding parts acronym. So basically it's saying once you've said that two triangles are congruent to each other, the leftover parts we can say are also congruent. So the acronym is corresponding parts of congruent triangles are congruent. Now we don't want to write all of that, so we just use CPCTC. Because in our congruency statements, there's only 3 pieces that we know are congruent, but if we conclude the actual triangles are congruent, then we can conclude all other parts are congruent as well. So we'll look at some examples here. So we'll get started with a little proof right away. So there isn't a whole lot of space here, so just try to write a little bit smaller if you can, unfortunately. I'll write my T-chart. I'm writing this, this part really small. Statements and reasons, because we know that that's there. Okay, so here's my picture. It says AB is parallel, so the vertical lines mean parallel to DE, and you have your parallel symbols already on there. And C is the midpoint. So let's start with those. AB is parallel to DE, and C is the midpoint of AE. And those are given. Okay, so let's see what we can conclude based on what we see so far. So I'm going to start with the midpoint because that one's really easy to write a statement. So C is the midpoint of AE. So I can say these two pieces are congruent. AC is congruent to CE, and that would be the definition of midpoint. Midpoint goes right in the middle of a segment. And then what else do I have here? Looking at this picture, I see these two angles, they're sticking out to me. Those would be vertical angles, so angle 1 is congruent to angle 2 by vertical angles. Okay, and then I also need to go back to one of my givens. So the two segments are parallel AB and DE. Now, let's see. Let's highlight these a little bit. This guy, this guy. Okay, I have this transversal. I actually have a couple transversals here, but based on what I have this segment, an angle here. If I can show that these two angles are congruent, then I can say the actual triangles are congruent by angle side angle. Now that's not what we're trying to prove. We're trying to show that BC is congruent to DC, but we'll get there with a triangle congruency. So I can say, let's label these 3 and 4. Angle 3 is congruent to angle 4, so now we're tying in our parallel line statements. These would be alternate interior angles. Oh, here's my transversal. Those are alternate interior. So that's fine for my reason. Okay, so now I have enough to say that triangle CBA is congruent. Now we need to be careful here, make sure we have the right letters matched up. So start with triangle C, because I know those two. And then B and D would correspond. Oops, C, D, and E and A. So this will be E, C, D, E, right? Make sure the letters are in the right order. Those are congruent by angle side angle. Okay, so now I'm not done yet because I still need to prove these segments are congruent. I'm going to switch colors here. So BC is this guy, and then DC here. So because I've said the whole triangles are congruent, I can already jump to BC is congruent to DC, and that's by our new statement, CPCTC, corresponding parts of congruent triangles are congruent. Because the entire triangle is, these two pieces have to be congruent as well. All right. So let's talk about one of our vocab words here, the median. So the median is a line segment from a vertex to the midpoint of the opposite side. Okay, so it starts at a vertex, so that's key. It has to start at a vertex and it goes to the midpoint. So you can see in the picture here, let me highlight this a little bit. There's my median, and we have the two congruent segments. One thing to point out, if I have multiple medians, so I want you to draw in the other medians from a vertex, and then draw it as best you can to the midpoint. So like these guys are congruent, and these, whoops, these pieces are. Oh my gosh. Okay. The medians, when they intersect at this middle point, it has a special name. This intersection point is called the centroid. And what that does is it splits those medians into proportional pieces. So the little piece is 1/3 of the length, and the larger piece is 2/3. Okay. So the centroid splits the median into 1/3 and 2/3 pieces. Another like way to think about that proportion is the big piece is double the size of the small piece. Okay, and we'll do some work with that on a practice worksheet. Right, so the centroid splits it into these proportional pieces. Okay, so let's look at a proof here. Oh, I don't really have a lot of room, unfortunately. So here's my T-chart. You're going to do some fill in the blank on the next one. That's why it's already kind of written out. So it says KP is a median, MK is congruent to RK. So let's start with that. So KP is a median, and MK is congruent to RK. And those are given, and then we'll label our picture. So MK is congruent to RK. So KP is a median, so we just talked about that. So that means that it splits the base, or like the base of the triangle, into congruent pieces. So I can say RP is congruent to PM. That would be definition of median, because this is a midpoint. Okay, so what else can I say here? I'm going to say that these guys are congruent. So, whoops, not R. PK is congruent to PK, and that would be our reflexive property. Okay, so what I've done now, my picture helps me see I have two congruent triangles. Triangle RPK is congruent to triangle MPK. Be careful with your letters. And that would be on side, side, side. So I'm trying to prove that angle 3 is congruent to angle 4. I have, let's label this 1 and 2, on the inside of my triangle. So I'm going to say angle 1 is congruent to angle 2. And that would be our CPCTC. So I can see that 1 and 3 are supplementary and 2 and 4 are supplementary because they clearly make that straight angle. So I'm ready to actually jump and say that angle 3 is congruent to angle 4. And that's based on supplementary or supplements of congruent angles are congruent. I will say, like, this particular proof is a little bit trickier. So if you're having trouble following all that, don't totally stress out. That one's a little bit more complicated. But I want you to look at the next one. So I've started the next one for you. There's a bunch of fill in the blanks here to kind of guide you through it. See what you can fill in. Give it a try. If you're not totally sure, just get something down on paper, and then you'll be able to check your answers. All right, so you can see I filled in those blanks with the green Again, these proofs are a little bit trickier, they're a little bit more complicated, so hopefully you're able to get some of these down. I would also take time to really label your picture. I think labeling the picture helps a ton as you go through this proof. So we had to use what we know about supplements and straight angles so that we could say that these two angles, these little guys, are congruent. Because I'm trying to show that these triangles are congruent here and here. Once I said those triangles are congruent by angle side angle, then I can say the base segments are congruent, making SZ the median. All right, so a little bit of algebra here, kind of take a break from proofs for a moment. So it says TW is a median, so it doesn't have to be like look perpendicular, go straight up and down, but we know it's a median, so these guys are congruent. ST is x plus 40. SW is 2x plus 30. WV, 5x minus 6. So we want to find these three segments. So based on what you know about medians, see if you can set up an equation knowing that these guys are congruent, solve for x, and then find the three segments. All right, so here's my work. Set up the congruency equation here. Solve for x, got 12, and then I plugged it in. Even though I know SW and WV are congruent, I would still just plug your x value into both equations just to double check that you actually did this algebra correctly. All right, so our next vocab word is altitude. So we have medians, now we have an altitude. An altitude is a segment from the vertex again to the opposite side, and it's perpendicular. That's already underlined, super important. Perpendicular to that segment. So wherever it's perpendicular to, we call that the base. So even though it's not on the bottom, we still call it the base. Perpendicular makes these nice right angles here for altitude, all from a vertex point. Okay, so you could have more than one altitude drawn on a picture, like that's fine. So I can draw an altitude from this point straight down, making that 90-degree angle as well. So we have a proof using altitudes. It's very similar to the ones we were doing before. Again, a fill in the blank here. So I want you to give this a try, see what you can do. Read through the given statements, label your picture first, see what I have to kind of prompt you, and see if you can fill in the missing pieces. All right, so here is my proof. So I started by labeling the picture based on the given information. So I can say right away that I have these two right angles, FDC and FDE, because that would be our definition of altitude. Okay, so we know they're both right angles, so we can just say right away that they're congruent. We don't have to say that they're 90 degrees and then that they're congruent. That's kind of implied, so that's fine. I use a reflexive property to say DF is congruent to DF. If you wrote something like FD, like that's fine, as long as it makes sense for the picture. And then those two triangles are congruent by angle side angle. The reason that's helpful is because I can then use our CPCTC to say that CD is congruent to DE. And that's what I would need to know in order to conclude that FD is a median. If it's a median, this is the midpoint, and it splits the segment into equal parts, right? So always kind of think in mind, well, if this is what I want to prove, what do I have to know about the triangle in order to say that? And then I use my conclusion down here. Okay, so we have one more vocab word. We're not going to write any proofs. We're almost done. The last one is perpendicular bisector. So again, we've had median and we've had altitude. So median, think the middle. Altitude, remember, is the perpendicular one. The perpendicular bisector, it kind of combines those two, but the difference here is that this is not necessarily from a vertex point. So it's a line or segment array which is perpendicular to the given segment and intersects the segment at its midpoint. Okay, so you can see the perpendicular bisector in blue. So it creates these two congruent segments and that 90-degree angle. Notice it is not always from a vertex. It can be, Like an equilateral triangle, the perpendicular bisect would be the same as the altitude, but in a lot of cases, when it's a scalene triangle, something like this, it's not necessarily from a vertex. Okay, so if I wanted to add into this picture the other two pieces, I could draw my median in green. So the median is going to end up at this same point, but it's going to be from a vertex, from the opposite vertex. So let's put this one. I could draw more medians, but we'll just draw them from that same direction. And then let me draw in the altitude in purple. So again, the altitude is also from a vertex, so it's not going to end up over here because that would not be a 90-degree angle. So I'm going to start at the vertex Z and go straight down, whoops, as best I can. So my altitude will be way over here because that's going to make perpendicular line from the vertex point as well. Okay, so those are the three vocab words we learned today.